In this video, we will see how to design, or you can say synthesize, a 4-bar mechanism by analytical method to generate a desired function or to generate a given function by using Freudenstein's equation. In previous session, we already discussed a procedure to solve this kind of numericals. I just briefly revise that procedure. So in order to synthesize that mechanism, that is to find out link lengths L1, L2, L3, L4, provided that a function is given to you, let's say y is equal to f of x and its range is given to you, then step by step procedure is like this. In first step, we are going to find out precision points, let's say x1, x2 up to xn depends upon number of precision points defined, that is n. So in first step, we find out x1, x2 up to xn by using Chebyshev spacing method. It may be by analytical approach or by graphical approach. In second step, we will find out precision positions y1 to yn by using a given function, that is y is equal to f of x. So after getting x1, x2, xn, we will get y1, y2 up to yn. So that in third step, you can write a precision positions, that is x1, y1, x2, y2 up to xn, yn. In next step, we will find out angle relationships like theta 1 to theta n and phi 1 to phi n by using these two relations. And in the final step, once we get theta 1 to theta n, let's say in this case it is theta 1, theta 2, theta 3, phi 1, phi 2, phi 3, then we'll use Freudenstein's equation for three positions given. We'll solve that three equations to obtain k1, k2, k3, and then finally we'll get dimensions of link lengths. So this is your procedure. Now we'll see how to use this procedure to solve a given numerical. So we'll read this numerical first. Using Freudenstein's equation, design a 4-bar mechanism to generate function y is equal to f of x. So I'll write given data. So function is given y is equal to x raised to 1.4. Then for an interval in x which is varying from 1 to 4. So range of x is given. So this x is varying from, it started from 1 and ends with 4. So range of x is given 1 to 4. The input link is to start from 30 degree and is to have range of 90 degree. It is starting from 30 degree for input link. So input angle is theta, starting position is 30 degree. So theta s is equal to 30 degree and its range means delta theta is also given having to have a range of 90 degree. So delta theta is how much? 90 degree. So delta theta is equal to 90 degree. Next, the output link is to start from 90 degree. So output link means phi, starting angle is 90. So phi of s is equal to 90 degree and is to have range of again 90 degree. So delta phi, that is range of phi output angle, is equal to 90 degree. Use 3 precision Chebyshev spacing. It is clearly mentioned here. Use 3 points or 3 precision points, and we have to use Chebyshev spacing. What you understand by this? Chebyshev spacing means in order to find that precision points, we have to use analytical method or analytical formula that we know. Next step, take the length of fixed link as 50 mm. So let's say we call L1 as fixed link and that length is 50 mm. So this is your given data for a synthesis problem, and what we need to find out is, so to find out, we need to find out different dimensions of that mechanism. L1 is known, so we need to find out L2, L3, L4 as input and output angles are known to us. So as per procedure we discussed, the first step in solving this problem is, so in solution part, we need to find out precision points. So first step is, step number 1 is to find precision points. As there are 3 precision points, I have to find out x1, x2, x3, and for this it is given, we have to use Chebyshev spacing. So analytical formula I have to use, and that formula is x of j is equal to, we know this, x of j is equal to half of, we know formula, it is, so here this formula is known to you, we know it is xj is equal to, that is x jth precision position is equal to half of xf plus xs, where these are nothing but starting position of x, final position of x, its addition. Here it is minus half of that again xf plus xs, actually here it is minus xf minus xs multiply by cos of this term, that is pi into 2j minus 1 upon 2n. So if you observe this formula, we come to know that in order to find xj, what we required is xf value, xs value, and number of precision position, as well as how much n is. So as we know, n is equal to 3, j means we are finding 1, 2, 3, and xf and xs is known to you. So xs is, yes, from here, x of s is 1, x of f is 4. So we'll use that to get x1. So let's say x1 is equal to, you can say for j is equal to 1. So when j is equal to 1, x1 is equal to half of xs plus xf. How much xs is 1, xf is 4. So it is 4 xf plus 4 plus 1 minus half of difference 4 minus 1 into cos of this term pi into 2 into j. How much j is here? First position. So j is 1 minus 1 upon twice n. Here it is. So if you solve this by using calculator, we will get this value is equal to, just will solve by using calculator. You can see here in calculator, when I am solving this, it is 2.5, that is half into 4 plus 1 is 5 by 2, 2.5, minus 4 minus 1 means it is 3, 3 by 2 is 1.5 into cos of pi into this term. So here n is, just we put value of n is 3. If you solve this, one care we have to take, you can see here, this must be in radian. So because we are putting here cos pi, so this mode must be radian. If you are solving by degree mode, you will get wrong answer. You can check that. So you must be put on radian mode. Otherwise, when you put on degree mode, instead of pi, put there 180. So this care we have to take while doing calculations. I repeat, for calculating this, it must be in radian mode, so that you can put like this. Or if you want to solve by degree mode, then here instead of pi, put 180, so that we will get right answer. So here x1 I obtain is 1.2. Likewise, I obtain next values. So x1 is 1.2. Next, x2, the same way we have to solve. So this remains same. It is xf plus xs. So it is 2.5 minus this one is 1.5, because 4 minus 1 is 3. 3 by 2 is 1.5 into cos of, here it is pi into 2 into j. Now it is 2 into 2. J is 2. For j is equal to 2. Pi into 2 into 2 minus 1 upon 2 into n. N is 3. So by solving this, we get value of x2. So how much x2 is, we'll check by calculator. And that value is 2.5. So x2 is 2.5. Similarly, I am finding here x3 also. So by similar approach, x2 is equal to, this remains same, 2.5 minus 1.5 into cos of pi into 2 into j. Now j is how much here? For j is equal to 3, as n is equal to 3. Up to 3 we need to find out. 2 into 3 minus 1 upon 2 into n. N of course is 3. So by solving this, we get x3 value. How much x3 is? x2 is 2.5. Now x3 is, we need to solve. 3.79. So we obtain x1, x2, x3. x1 is 1.2, x2 is 2.5, x3 is 3.79. You can check our range is 1 to 4. So x1, x2, x3 must be lies between that. So xs is 1, so x1 must be greater than this. So you can check it is 1.2, so more, right it is. It is 2.5, 3.79. 3.79 must be less than this, so right it is. So you can cross check these answers. So I completed first step here. I find out precision points x1, x2, x3 between the range 1 to 4 by using Chebyshev spacing. In second step, as we know in second step, once we get x1, x2, x3, we need to find out y1, y2, y3 by using given functions. What is function given here? You can check y is equal to x raised to 1.4. So by using this function, step 2, so in step 2, I have to find out y1, y2, y3. And for finding this, I will use function y is equal to x raised to 1.4. Therefore, at the same time, remember range is given for x but not for y. So we can find out the range also. So that I have to find out actually ys first, that is starting position of y, because xs is given, xf is given. You can check here in the given data, xs is given, xf is given, but ys and yf is not given. So by using this function, I can find out all values of y, that is for output link. So ys is equal to, our function is x raised to 1.4. So it is x raised to 1.4. For ys, this x is xs. So if you put here, xs is how much? 1. So 1 raised to 1.4. Of course it is 1 only. Then I can find out next value, that is y1. So y1 is equal to x1 raised to 1.4, which is nothing but x1 is how much? Just we find out x1 is 1.2. So 1.2 raised to 1.4, it is, we solve it is 1.29. Similarly, I get value of y2 by putting x2 raised to 1.4. x2 is how much? 2.5. So it is 2.5 raised to 1.4. Answer is 3.60. So I obtain ys, y1, y2. Next one is y3 and yf. So y3 is equal to, again same way, x3 raised to 1.4 and x3 is 3.79. We know x3 is 3.79. So 3.79, this your answer is 6.45. And finally yf. Yf is nothing but xf raised to 1.4, and xf value is how much? Final value is 4. 4 raised to this 1.4. Your answer is 6.96. So I find out y1 to yf by using function y is equal to x raised to 1.4 by putting all values of x. So in third step, you can write precision points. And therefore, in step 3, 3 precision points are, because we need to find out precision points. In some examinations, up to this can be asked for 2 marks. Determine precision points by using Chebyshev spacing method. 3 precision points are, I will write it as x1, y1. Okay, x1 is 1.2 and y1 is 1.29. x2, y2. Precision points means intermediate point. xs, xf is known to you. ys, yf is known to you. So y2, x2. x2 is nothing but 2.5. y3, y2 is 3.6. So 2.5, 3.6. x3, y3. x3 is 3.79. 3.79 and 6.45. So these are the precision points. Now we need to find out angles in the fourth step. So in step 4, we need to find out angles, and for finding angles we have to use angle relationships, that is basic equations. Theta of j is equal to, we know equation, theta j is equal to theta s plus delta theta by delta x into x of j minus xs. Now we can put values for j is equal to 1, 2, 3. Let's say I am finding it for 1. Suppose first theta 1 is equal to, what is theta s value known to you, given to you, theta s. See here, theta s is known 30 degree. So I am writing here. Theta s is 30. What we need is theta s, delta x and this. So theta s is equal to theta 1 I am writing, theta s is 30 degree, it remains same, plus delta theta by delta x. Delta theta range is 90 degree. Delta x, how much delta x is? You can check, range is 4 minus 1, so it is 3 into xj minus xs. How much xj is? Xj means x1, because I am finding for first position. So it is x1 minus xs. So just put values here. X1 is how much? We know it is 1.2. So instead of this, I will put 1.2 minus 1. Okay. If we solve this, we will get answer. So solve by using calculator. So you can see, I just put in calculator to get answers. It is 30 degrees theta s as per this formula. 90 by 3 into 1.2 minus 1 will get 36 degree. Okay. So theta 1 is 36 degree. Similarly, I am not writing now here. Similarly, we can find theta 2 and theta 3. Just we need to put formula. What is change here? 30 degree remains same. This also remains same. So I am writing here, you can check. 30 plus this 90 by 3 means 30 only. So 30 plus this 30 into xj minus. So x2 minus xs. Xs is 1. It also remains same. Here it is x3 minus xs, that is 1. And so that we will get value by putting x2 and x3. Change only. So how much x2 is? Let's put x2 and x3. x2 is 3.6. So I am changing that. x2 is 2.5. Yes. So it is 75 degree. And x3 is, x3 we check, x3 is 3.79. It is 113 theta 3 value, 113.7. 113.7. Okay, and similarly we can find out phi 1, phi 2, phi 3. So phi of j is equal to phi of s plus delta phi upon delta y into y of j minus ys. So put value. Let's say phi of 1 is equal to, for j is equal to 1. Phi s, initial value is, for phi initial value is how much? You can check in the given data. Phi s is 90 degree and its range also 90 degree. Therefore, it is 90 plus 90 degree divided by delta y. Now you can check, delta y is 6.96 minus xs is 1. So it is 5.96. Here we need to find out delta y. 6.96 minus 1 into yj. Yj means y1. How much y1 is? 1.29. 1.29 minus ys. Ys also 1. And this value, its answer is 90 degree plus 90 upon, instead of 3 it is 5.96 into, it is 1.29 minus 1. So you can check, the first answer is 94.36. 94.36 degree. Similarly, we can find out phi 2. So what is change here? Phi 2, this remains same, 90 upon 90, 5.96. Instead of y1, it is y2 only. So y2 is 3.6. 3.6 minus 1, you get phi 2. And for phi 3, this remains same. Only we have to put y3. How much y3 is? 6.45. here it is 6.45 minus 1, just solve it. So it is 129.2652 26 degree, and here it is for third one. So 172.29, it is 129.12 actually, and it is 172.29, or you can say 1 actually. I'll just check once again. It is 171.86. Okay, so likewise we get value of phi 1, phi 2, phi 3, theta 1, theta 2, theta 3 by using angle relationship. And then last step, use Freudenstein's equation to get value of k1, k2, k3. So after getting this theta 1 to theta 3, phi 1 to phi 3, step number 5, use Freudenstein's equation to find k1, k2, k3. So my equation is, basic equation is k1 cos phi, we know k1 cos phi minus k2 cos theta plus k3 is equal to cos of theta minus phi. Now this equation I have to use for 3 values of angles which are find out. So let's say use it for first position, second and third. So for first position, when theta is equal to, theta 1 I can say, theta 1 is equal to 36 degree, you can check here, theta 1 is equal to, theta 1 is 36 and phi 1 is 94. So when theta 1 is 36 degree, phi 1 is 94.36 degree, then my equation is k1 cos of 94.36 minus k2 cos of 36 degree plus k3 is equal to cos of 36 minus 94.36, equation number 1. Similarly, we can write for equation for second and third position. So when theta is equal to, second position, when theta is equal to 75 degree, you can check here also, yes, 75 and 129. So when theta 2 is equal to 75 degree and phi of 2 is equal to 129 point, so it is 129.112 10 degree. Then my equation is k1 cos of phi is nothing but 129, k1 cos 129.1 degree minus k2 cos of 75 degree plus k3 is equal to cos of theta minus phi. How much theta is? 75 minus 129.1. Okay, so it is equation number 2. Similarly for third position, when theta 3 is equal to 113.7 degree and phi 3 is equal to 171.86 degree, then our equation is k1 cos of phi 171.86 minus k2 cos of theta 3 113.7 plus k3 is equal to cos of 113.7 minus 171.86. equation number 3. So solve these three equations, simultaneous equation, to obtain k1, k2, k3. You can solve by using calculator. So solving equation 1, 2 and 3. Solving that we will obtain, you can check value, k1 is equal to minus 0.436, k2 is equal to minus 0.326 and k3 is equal to 0.2271. So we obtain k1, k2, k3 by solving these three equations. And once you obtain k1, k2, k3, L1 is known to you. So in the last step, by using formulas, step number 6, we know that k1 is equal to L1 by L2. So k1 is known to me, L1 is known to me, which is 50, and hence we will get value of L2. So k1 is how much? K1 is minus 0.436 is equal to 50 upon L2, and hence L2 is equal to 114.65 mm. This one is L2. Similarly, you know K2 is equal to formula L1 upon L4. Put that value, we get, that is put value of K2 and L1. K2 is minus 0.326, L1 is 50. So we get L4. L4 is 153.37 mm. L1 known to us, L2 we obtain, L4 we obtain, last one is L3, and to obtain L3 we use K3 equation. We know that K3 is equal to L1 square plus L2 square plus L4 square minus L3 square upon twice L2 L4. So put value of K3 0.2271, L1 is known, L2 is known, then L4 is known, only L3 is remaining. So by solving this we get L3, and L3 value is 197.80 mm. So we obtain value of L1, L2, L3, nothing but we have done dimensional synthesis of a 4-bar mechanism. I repeat step by step procedure what we followed to solve this numerical in brief. So we know this is our given data. Function y is equal to x raised to 1.4. X varies from range xs to xf 1 to 4. Theta is given, theta phi is given, delta theta delta phi given, number of precision points given, and it is asked to find out length of the 4-bar chain mechanism for using Freudenstein's equation, as well as to find out n we have to use Chebyshev spacing. So the first step, determine x1 to x3 by using Chebyshev spacing formula as it is mentioned here. Hence I use this formula. Use radian mode as I instructed in lecture. Use x1, x2, x3 relations. So we get x1, x2, x3. After that, by using function, we will obtain y1, y2, y3. Write down 3 precision points x1, y1, x2, y2, x3, y3. After that, by using angle relationships, that is theta j and phi j, you obtain theta 1, theta 2, theta 3, phi 1, phi 2, phi 3. Once you know all these angles for 3 positions, then we can use Freudenstein's equation to obtain k1, k2, k3. So use this Freudenstein's equation for 3 positions, solve these 3 equations, you obtain k1, k2, k3, and by using formulas of k1, k2 and k3, we get value of L2, L4 and L3. This is complete procedure to solve this numerical. One more thing I want to highlight, sometimes they ask you along with this sketch the arrangement. In that case, we need to draw a 4-bar mechanism by using dimensions given. So I can draw, let's say it is L1 is 50 mm, L2 is 114, theta is known to you, we can draw for any one position out of this. Say theta is 36 suppose, so I can draw L2, I am drawing approximately. So L1 is known to me, theta is known to me, I can draw that L2 length at that angle. So let's say this is L2, then I can mark L3 at L3 I can draw, or instead of that L4 we can draw, as phi is known to us. We are drawing for first position 94.36. So we can draw it. 94 means more than 90. Okay. So somewhere like this, depends upon value. So that we get value of L3. Means I mark L1 first, L2 and L4 at angle theta 2. You can take any one angle, phi 2, we get L3. So in addition to this, in addition to solve by analytical way, sometimes they ask you sketch the arrangement. So you can draw it by using a scale if asked. This is our complete procedure of a dimensional synthesis by analytical approach and using Freudenstein's equation.